Okay, hey, here we are, section 9.2, and 9.2 is L'Hopital, and you have worked with L'Hopital before when we worked with limits last year in AB, and it's a nice little review session, plus we go a little further than what we did last year. So we know L'Hopital, this French mathematician, credited with how to work with limits. So, hey, one thing to note, his last name has been can be written also with an S in there. So sometimes on the AP exam that was a couple of years ago, they put an S in there, and people were kind of thrown by that. But there are two different spellings of his name. So L'Hopital. This theorem states that under certain conditions, the limit of the quotient f of x over g of x is determined by the limit of the quotients of the derivatives. So if the limit of f of x over g of x equals either 0 over 0 or infinity over infinity, plus or minus, doesn't matter, then we are able to use L'Hopital's rule and take the derivative of the numerator separate from taking the derivative of the denominator. I wrote equals, you know what, let's just say that they tend to go to 0 over 0 because we shouldn't really say they're equal. And if you say they're equal on the AP test, they get really angry. Steps for using L'Hopital's. Test both the numerator and the denominator. Test them separately. So it's a lot of work to show the limits on them. We'll work through it one time like that, and then you can take some shortcuts. But I do want you to know how to do it for the AP exam. If the L'Hopital's rule applies, meaning I get 0 over 0 or an infinity over infinity, then I can find the derivative of the numerator and the derivative of the denominator. And hopefully from there, I can get some limit out of that. Once I use like substitution method to put my numbers in, I can evaluate the limit. If necessary, I can repeat L'Hopital's over and over as long as I'm coming up with infinity or 0 over 0 or infinity over infinity, plus or minus, doesn't matter whether it's positive or negative. Okay, so let's take letter A, for example. If I put -1 in, I'd have 2 minus 2 on top. I can see that that's 0. If I have -1 on the bottom, I also get 0. So for a multiple choice question, I would probably do that quick analysis and then apply L'Hopital's rule by taking the derivatives. However, if it is on a free response question, what we need to do is work off to the side or somewhere, 2x minus 2 or 2x squared minus 2 equals 0. I need to make that statement, and I need to make a separate statement about the denominator, that x plus 1 goes to 0. And this creates the 0 over 0 case. So L'Hopital rule applies. I would write that out, that you have the 0 over 0 case or the infinity case, and therefore L'Hopital's rule applies. So then now, do you remember how to use L'Hopital's? We're going to take the limit as x goes to -1. I take the derivative of the top, 4x, take the derivative of the bottom is 1, and I try substitution. I would have 4 times -1 over 1 gives me -4. My limit's -4. So L'Hopital, very nice to use. It does make things simplified as we take derivatives usually. They get a little bit simpler function each time we take a derivative. If I throw infinity here, I can see very quickly this is an infinity over infinity case, which means that L'Hopital's rule applies. If I were working on a free response question, which last year there was one for L'Hopital's, I would use separate limit statements to show that this one's going to infinity and work the denominator, 2x squared plus 1. I would like you to practice this once in a while at least. That gives me, it gives the infinity over infinity case. So L'Hopital rule applies. And I'm going to go into a limit as x goes to infinity. I would have 10x over 4x. In this case, I really could cancel my x's, so this is going to give me 10 fourths or 5 halves. Otherwise, I could go into L'Hopital's again because really honestly, I'm infinity over infinity. But I could simplify 10x over 4x and get that. Oops, there must have been a C somewhere. Where was C? I didn't see C. There it is. All right. Throwing in 0. E to the 0 gives me 1. So I get 1 minus 1. I get 0 on top, 0 on bottom. L'Hopital's rule applies. I'm just going to go into, you understand that you have to write each limit separate, but let's just go and do L'Hopital's. I knew it was infinity over infinity case. And the limit as x goes to 0. The derivative of e to the 2x is 2. E to the 2x over a 1. I can put in 0. I get e to the 0, so I get a limit of 2. Over and done. D, infinity. The limit of x or limit of infinity, well, natural log, it does kind of grow. I guess as we got out to infinity, it would go to infinity. So I'm seeing this as infinity over infinity case. Let's apply L'Hopital's by taking derivatives. 1 over x over 1. That means I have 1 over infinity. That's going to go to 0. Negative infinity, I can see that this top would be infinity, wouldn't it? And e to the negative infinity means e to infinity. I would get infinity over infinity case on this. So infinity over infinity case. And that means we can use L'Hopital's rule. Let's use L'Hopital's rule. How many we got to do here? Gee, the limit as x goes to negative infinity. We'd have 2x over negative e to the negative x, right? Whew. E to the u is e to the u times u prime. All right. So now I would, I still have infinity over probably what would be negative infinity, but that's still a L'Hopital, so we can apply a L'Hopital on this one. The limit as x, I don't think we'll have to do any more because our numerator is going to stop, and e to the negative x, and the derivative of negative x is negative, so I'd have negative times negative. This looks like this will be a positive e to the negative x. And if I put in, that'd be 2 over e to the negative infinity, which makes this positive infinity. 2 over infinity looks like we're headed to 0. So this is my scratch work over here. I might remove that if I were on the AP exam. Okay. If I were on the AP exam, though, I would have to definitely show each limit, numerator, denominator, and I'd have to do it twice, wouldn't I? I'd have to do it once for the initial and then a second time here to sweep us over to that other one. So it would be a lot of work to show. There is an F, must be down below. Sine x over x. If I put 0 in sine of 0, the limit, I guess it isn't that bad. The limit of sine x is 0. The limit as x goes to 0 of x is 0. This gives me the 0 over 0 case, which means L'Hopital's applies. So let's take derivatives. I would have the limit as x goes to 0. Derivative of sine is cosine. Derivative of x is 1. Cosine of 0, which you could actually leave that answer, couldn't you? If you were unsure of what the cosine of 0 is, you could just leave it cosine of 0 for the AP test. But it does turn out to be 1. How about sine x over sine 3x? Well, I recognize this as 0 over 0 case. I'm just going to write that over here rather than showing all that limit. And I'm going to have the limit as x goes to 0. This is using L'Hopital's. So sine is cosine. Bottom is cosine. 3x, chain rule, derivative of 3x is 3. So throw in 0, we get 1 over 3 times 1 gives us 1/3. This one looks kind of fun, doesn't it? So I'm going to slow this one down just because I'm not quite sure where this is headed. This would be 2 over e to the positive x. And if I put infinity in, that's going to go to 0. And what about the denominator? As x goes to infinity, 4 plus 1 over e to the x. And that would be a 4 plus 0. So that would be 4. I would get 0 over 4. Answer's got to be 0 then. We could even write 0 over 4. So that gives us 0. Because it wasn't a L'Hopital, was it? I really didn't even need L'Hopital. So don't always assume that it's L'Hopital. The back is just reiterating when L'Hopitals can be used. And then there are various other indeterminate forms. So this is where we take a continue forward from where we left off on A-B stuff last year. In the indeterminate form of 0 times infinity. In order to use L'Hopitals, we always have to have it in that quotient form of 0 over 0, infinity over infinity. So how do I work with something like this? Well, I would get, this would be 0, wouldn't it? And this would be, how do I want to write this? I'm going to show the limit as x goes to infinity of e to the negative x would be the limit as x goes to infinity of 1 over e to the x. That is a 0. And the other one, I get limit as x goes to infinity of square root x. Well, that would head to infinity. So I indeed have this 0. Let's say the case here is 0 times infinity. But I can't use L'Hopitals for that, and it is an indeterminate form. You would think it'd be 0, but it's not. So what I want to do is I want to establish a quotient. And there's a really cheesy way to do that on this one. Square root of x is numerator. The negative exponent moves that down below. And now I have a quotient. And I would have infinity over infinity case, wouldn't I? Because the limit as x goes to infinity of square root x is infinity. And the limit as x goes to infinity of e to the x, our denominator, our new denominator, it is infinity. So infinity over infinity case, L'Hopital applies. I keep doing an extra line. So let's go into derivative of top and bottom. Limit as x goes to infinity. Derivative of square root x is 1 over 2 square root x. And the derivative of e to the x is e to the x. If I put infinity into x on top, I would have 1 over huge. That's going to drive to 0. 0 divided by e to the x, which is a number, is still going to be 0. So I'm going to get 0 on this one. Yeah. I don't think I would probably write in my head. This is my little thought bubble, but that's going to equal 0. Another way you could have written this one is this could also be structured as denominator times that other denominator. And then I end up with 0 times a number, and that's going to give me 0 on the bottom. All right, that was I. Let's look at J. What about infinity minus infinity? Indeterminate. I don't know how big the first infinity was in comparison to the second one. I still need to try to write it as one fraction, so I have a quotient trying to get that 0 over 0, infinity over infinity type case. So let's make a common denominator. And I can see what that common denominator would be. My LCD is natural log x times an x minus 1, isn't it? So over here, I want to multiply by x minus 1 over x minus 1. And over here, I want to multiply by natural log over natural log. And this will take me to a limit as x approaches 1 from the right. I would have x minus 1 Common denominator is going to be an x minus 1 times natural log x. The other part, here's my numerator, minus natural log, whoops, what the heck? Natural log of x, and then common denominator, same. So does that help us out? Well, let's analyze. Separate little analysis for the AP. I would have x minus 1 minus natural log of x. And yeah, so natural log of 1 is 0. So I'd have 1 minus 0 looks like a 0 numerator. Okay, that will work for L'Hopital. And then the other thing we want is let's analyze the denominator. As we go to 1 from the right, our denominator was x minus 1 natural log of x. That's going to give me 1 minus 1 times a 0, and 0 times 0 is 0. So we are definitely a 0 over 0. L'Hopital applies. So let's do some derivative work. Derivative on the top, the limit as x goes to 1 plus. Here we are continuing on our path using L'Hopital. 1 minus 1 over x. Ew, the bottom. Little product rule, eh? Okay, so derivative of the first times the second minus derivative of the second multiplied by the first. That looks messy. I think I need to simplify. I'd have 1. You know what? While I'm writing this one, I'm going to make this one fraction. That's going to be an x over x, so an x minus 1 over common denominator x. The bottom would be looking like natural log x minus, distributing through would give me 1 minus 1 over x. Just really being careful here. How is that helpful? So, probably not helpful, huh? X, we'd have x minus 1 over that x. That'll get multiplied by a natural log x minus 1 plus 1 over x because I distributed through. Okay, let it go to 1. And my numerator is 0. What's the denominator? 1. That'd be a 0 minus 1, dang it, plus 1, getting a 0 over 0 case. And I'd have to explain that differently. Let's just use some arrows to show what it's headed towards. This looks like I should go into one more bout of L'Hopital. Yuck. Okay, limit x goes to 1 from the right. Numerator is 1. Oh, good Lord. I don't want to do that. So, either I could use big product rule, or I could replace this with x natural log x, which is going to be product rule, minus x plus 1, right, if I distribute through. Send that through, and it simplifies to that. So I do definitely have to use product rule. That's going to be a natural log x plus derivative of that. I kind of lost track for a moment here. I'm sorry. All right, so x, natural log x, and then 1 over x times 1. I'm sorry, times x, because the derivative of natural log is 1 over x times the first, which is x, minus 1. Is this going to get us anywhere? The limit as x goes to 1 from the right, we get 1 over natural log of x plus 1 minus 1. Ew. So that's knocking each other out. And then as I put 1 in, that's going to give me 0. I'm going to get 1 divided by 0. And that's not the answer. I should get 1 over 2. Did I mess up a sign? See, I feel like I messed a sign up along the way. I've got this, and then one over x. I should have an x. See, somewhere along the way. This should turn out to be 1/2, you guys, and I don't want to take any more of your time, but maybe you saw where I made a mistake. Perhaps I'll come back and do that problem separate, and you can watch the video if you didn't catch my mistake, because I've got to dig through it too. Okay, other indeterminate forms are shown here. And final one. Okay, this needs to be cleared. Final one. This is of the style, let's see, this would be infinity, wouldn't it? And this would be infinity there, so this would be a 0. This is an infinity raised to the 0 indeterminate style. So I've got infinity to the 0 case. And I would need to get it to quotient in order to use L'Hopital. I've got variable x in the main level as well as in the exponential spot. So what I'm going to do to both sides, because I want to be able to move that 1 over x down, I'm going to natural log both sides. So we're going to ln and we're going to ln. But I can move the ln inside to the limit, or to the expression work, because the limit of the expression come into natural log is going to be the natural log of that same stuff. So this will really look like a natural log of y equals the limit as x goes to infinity of natural log e to the x plus x. That 1 over x can come down and it'll be written over x. Ooh la la! There's our quotient. We do have a nice little quotient. The natural log of infinity on top would be infinity, marker. X on the bottom is infinity. This is gravitating towards an infinity over infinity case. Let's rock and roll with derivative work. So L'Hopital says for this limit, we can take the derivative of the top. Derivative of the top is going to be u prime over u. So an e to the x plus 1 over e to the x plus x. Derivative of the bottom is nice. That's just a 1, isn't it? All right, so now I go into infinity. Essentially, I'm just kind of ignoring this. I bet you did too. So this, I'm seeing infinity over infinity case again. L'Hopital again. Okay, so let's L'Hopital it. E to the x on top over e to the x plus 1. Still looking at infinity and over infinity case. L'Hopital it again. Limit as x goes to infinity, e to the x over e to the x. That has an answer of 1. But that is not quite our answer, because remember the left side is staying as natural log y. I want to know what y equals, not what natural log y equals. So this was natural log of y equals 1. And we would have to e both sides to release the y. And that gives us y equals e to the first, or my limit is e. That was a clever one. All right, that is it. Homework, I think, is a worksheet that follows.